In this video, we present Taxonomizer, an interactive tool for constructing fully labeled hierarchies from multivariate data. Our objective is to create a visual analytics tool that allows mainstream users to construct a taxonomy for the attributes in multivariate data. Our visual tool has 6 components. We will use a running example to illustrate the different parts of the visual tool. We will be using a university dataset that has 14 attributes. The attribute names can be seen on the leaves of the hierarchy tree. The semantic space plot shows how the different data attributes are related in the semantic space. Words with similar meaning are closer to each other in the semantic space. If the user is not satisfied with the position of the labels in the semantic plot, they can click on it to get alternatives. For example, staff should be closer to academic. The user can click on staff to get a list of alternatives. Faculty seems like a better alternative, so the user replaces staff with faculty by clicking on it. The data space plot shows the statistical relations between the attributes, such as correlation and the mutual information. The hierarchy tree shows the structure of the taxonomy. The attributes of the dataset are used to label the leaves of the hierarchy tree. If a user hovers the mouse over a node in the hierarchy tree, the corresponding nodes in the data and semantic space plot change color to make it easy to identify them. The nodes in the tree are colored using the done index. The left side represents the done index of the data space and the right side represents the done index of the semantic space. Here we can see that housing and athletic form a decent cluster in the data space but not in the semantic space. For the user to be able to label the internal nodes of the tree, groupings in the hierarchy tree have to be semantically consistent. In this tree, it will be difficult to label the nodes with athletic and housing. Therefore, we have to merge the semantic space and the data space to create a tree in which the internal groups are semantically related. The cophonetic plot shows how faithfully a dendrogram captures the pairwise distance between the original data points. The blue line represents the data space and the yellow line represents the semantic space. We can see that at this point the tree is representing the data space quite well, but the semantic space is not well represented. The control panel allows the user to merge the two spaces using minimum, maximum and average weight. The user can adjust the weight using a slider. We slide the weight to the right so the semantic space is better represented. Now the tree is more semantically consistent. There are 2 layouts for the tree, node depth and cluster distance. The collapse slider can be used to collapse the height of the tree. The user can alter the shape of the tree using the join features. Once the user is satisfied with the structure of the tree, they can start to label the internal nodes of the tree. The user can double-click any of the internal nodes of the tree to label a node. When the user double-clicks a node, they will get a set of suggestions in the Word Suggestions panel. They can use a word from the suggestions. Here the user chooses the word education to label the internal node. If they can't find a suggestion, they can use their own label by typing it in a text box. Here the user types in demographics. The user then continues to label the inner nodes to complete the construction of the taxonomy.